मैंने फर्स्ट लेक्चर में पोलर प्लॉट डिज़ाइन के लिए स्लाइड को शेयर किया था। यहाँ पे हमने डिस्कस किया था टाइप 0, टाइप 1, टाइप 2 एंड टाइप 3 सिस्टम एंड सिमिलरली ऑर्डर 1 एंड ऑर्डर 2, ऑर्डर 3 एंड ऑर्डर 4 सिस्टम। हमने डिस्कस किया था व्हाट इज द प्लेन ऑफ दिस what type of this plane. This is the GSHS. Now always we discussed about type. What is the type? From this point polar plot started and order at this point polar plot is terminated. This is the basic difference between type and order for designing purpose, right? But we know what is the type, number of 0 at origin, that is known as the type of the system, or maximum power of denominator. Maximum power of denominator of S is known as the order of the system, right? Now we are going to solve some numerical problem on the basis of this trick, or we can say this diagram. Now see here, discuss. Now if I am going to plot the Nyquist plot of this this type, this is a general function, or okay, I have already discussed it. This type and order concept is only applicable when there is no 0 in GSHS, right? Like if there is the 0, like this function, this type of this trick is applicable for this type of function, but if there is the 0, something like this, if there is a 0 in GSHS, like S plus 2, S into S plus 1, sorry, this become S plus 3, right, or S plus 2, then this trick is not applicable. Only applicable if there is no 0, then this trick is applicable. Now see here, this is the function k divided with S plus a. Now there is no 0, means we can use this concept here. Now what is the type of this system? The type of system is 0, means this function is the Nyquist polar plot of this function is started from here, because here we know there is the type 0, there is type 0. Now see here, type 0, and our polar plot always started from type. That means this polar plot started from this point. And what is the order of the system? Order means what is the maximum power of S here. Maximum power of S is S to the power 1, means order of system is 1, means this plot should be going to terminate at this point. Reason is that order of the system, if order is 1, then our termination is going like this, means our function design like this one. Clear? If our polar plot started from this point and terminated at this point. Now similarly here, our polar plot started from this point and terminated at this point. Why I am writing here omega is equal to infinity, omega is equal to 0, I will discuss in coming lecture. But just remember that I am going to plot or approximate plot how our polar plot look like by seeing only the transfer function of the system. Now the next part is here, if I am adding S plus B, another 0, another pole, if I am adding another pole in this system, then what happen? Our tail remain at this point and our head shifted to this location. Now see why. What is the type of this type of the system? Type 0, and type 0 always started from this point. We already know that. Type of this type means from this point polar plot is started, means polar plot is started from this point. Clear? Similarly in our plot, the polar plot is started from this point. Clear? Now what is the order of this system? What is the order of system? Now let's see the maximum power. Maximum power of this system is S into S, that will become S square, means order of system is 2, means if the order of system is 2, then plot go and terminate at this point. We know plot terminated at this point for order of system. Clear? Now so the approximate plot of this type of function, if a function to look like 1 divided with S plus 1 and S plus B, S plus 2, this is a similar function, then their polar plot goes in look like this. Okay, what is the value at this point omega, what is the value of omega at this point, what is the value of omega at this point, what is the value of this range, we will calculate here after this lecture, but just we are going to discuss how we use this trick here. Okay, now again when I am going to add another pole, I am going to add another pole in, so means like s plus a, just we add something 1 s plus c here, s plus c here, look like this. Okay, then how look like our function? Now see here, what is the type of this system? Our type of the system is 0, means our polar plot started from this point. You already saw that polar plot always started from type, means polar plot started from this point. And what is the order of the system? Order of the s and s, that become sq, means order of the system is 3. If the order of system is 3, our polar plot will be terminated in this coordinate, right? Means polar plot started from this point and goes and terminated in this point. See here, polar plot started from this point and goes and terminated at this point. We will calculate. We will calculate what is this value range, what is the value of omega here, what is the value of omega here. But I am only calculating the approximate plot. Now see here, when I am adding a 0, when I am adding 0 pole at origin, then what happened? See, our whole plot shifted in 90-degree clockwise direction. This part goes in this direction here, and our tail is goes at this point, means our whole plot shifted in 90-degree clockwise direction. And why? See why. Now what is the type of this system? Type of system is 1. This is the 0 type, this is the 1 type, means type 0, type 1, type 2, type 3, means polar plot started from this point, look like this. And what is the order of this system? Order of system is 4. Order of system goes here and terminate at this point. Clear? That is the order of the system. Similarly, when we goes here and see what is the type of the system, the type of the system, again when we now see what is the difference between these two plots. When we add s, means there is a 1 0, then our plot shifted 90-degree plus 90 degree in clockwise direction, that become minus 90 degree in clockwise direction. Clear? Similarly, if we add another pole at origin, then our plot again shifted 90 degree in clockwise direction. If we add another pole at origin, then what happened? Our pole again shifted 90 degree in clockwise direction. See. Similarly, this is nothing. What is this plot? This plot, what is the order of the system? Order of system is 2. Means if the order of system is 2, what is the type of the system? If the type of the system is 2, means what is the type of this 2? If type of system is 2, then our pole started something from here or here. Maybe plot started from where, maybe from here. I will discuss in coming lecture. But assume that our plot started from this point. Clear? And our plot always started from this point here, since there is no 0 here. Okay, and what is the type, what is the order of the system? Order, there is a 3 and 2, 5, means this is order 1, order 2, order 3, order 4, order 5, order 6, order 7, order 8, order s. This is the continuous going on when we moving from in clockwise direction, right? Order 1, order 2, order 3, order 4, order 5, order 6, order 7, order 8. Okay? Means our polar plot will be designed like this. Now see what is the difference between these two plots. When we adding 1 0 at one pole at origin, then what our polar plot again shifted in plus 90 degree. Now this all happen in all cases. Now see here, when we add 1 0, then become 1 pole at origin, then our polar plot shifted 90 degree in clockwise direction. Again clockwise direction here. Similarly, we can draw what is the type of the system. Type of the system is 1. Type of the system is started from this point, and what is the order of system, or due to order 2, our polar plot will be terminated at this point. Means this our polar plot goes and terminated at this point. I will calculate the omega is equal to 0, omega is equal to infinity in coming lecture, but again I am repeating, I am only going to see how the approximate polar plot look like. This problem is this trick is only applicable when there is no zero in a GSHS. Always remember that. This cannot be applicable like for this type of system. Clear? For this type of system, I have already made a video on. Go and see how we can calculate the polar plot for this type of system. Again, similarly, when we add s is equal to s, again another pole at origin, then our polar pole plot shifted in 90 degree. Means यहाँ पे हम एक conclusion हमारे पास क्या मिला? When we add 1 0 at origin, that is the main part, at origin, 1 0 at origin, then our polar plot shifted, complete polar plot shifted 90 degree clockwise direction. Complete polar plot. When we add 1 0, like now see here, from here to here, 1 0, one pole, when we add one pole, sorry, that is not 0, this is a pole. When we add one pole at origin, then our polar plot shifted 90 degree in clockwise direction. But when we add a pole which is not located at origin, something somewhere, but not located somewhere, we add here, but we cannot add at origin, then what happen? Our polar plot tail remain at same position, but the head of the polar plot shifted 90 degree in clockwise direction. Now see here, when I am adding a pole which is not at origin, then what happened? 90 degree shifted. Again we are adding another pole, then our head of the system shifted 90 degree in clockwise direction. Only head, tail remaining at this point. Now see the basic difference between two. Here when we adding a pole at origin, then our complete polar plot shifted in tail and head, both are shifted in 90 degree in clockwise direction. But when I am adding only a pole which is not at origin, then our only head of the polar plot shifted in 90 degree direction. Clear? Now, this is the basic concept of this. Now look at careful. Now this is the basic concept of order and type 1 of the system, how the polar plot look like. For if I have a function which have no zero at no zero in their transfer function like GSHS, then how the approximate polar plot look like. This is the polar plot we already discussed in our previous video. What is the Nyquist plot? Just we draw the mirror image. Or this become the Nyquist plot. Just we draw the mirror image. Always we put mirror at real axis. We cannot put mirror at this axis. If we put mirror at this axis, then our image become like this. But this is not true. Always put mirror at real axis. Okay. Similarly, when we put a mirror at real axis, then our polar Nyquist plot, the polar plot converted into the Nyquist plot. Similarly, when we add then our polar plot converted into the Nyquist plot. Similarly, we discussed what is the value of omega, what is the value of this quantity here, what is the value of the length in coming lecture. But we are only going to see what is the approximate Nyquist plot of our system if there is no zero at origin. This is our task here. Okay. Easily we can see how type and order of the system is important for calculation of polar plot, and this slide is very important here. If you know this part, then you can easily solve this type of problems. In coming lectures, I am going to discuss some problem based on this concept. Now, thank you very much.